Now this is same time I tried low voltage power supply, so that's why I use the two components along with this transformer. One TDPC 3510, which is 1000 volts 35 ampere rectifier, and 3300 microfarad 35 volt electrolytic capacitor with full bridge rectifier 35 amperes 1000 volt metal bridge one. So first we tend to do same rectifier I used to test this unit. So in case we have wires, and these wires have the same type of clips, so which clips easily fits this same type of symbols, which symbols easily fits this rectifier without chopping mark. And this is there's a AC mark and there's a positive mark, meaning diagonal opposite. This is a AC pin and there's a diagonal opposite and another AC pin, and this is a positive pin, and similarly diagonal opposite this negative pin. Now I remove the wires just for safety reasons, and now I connect this rectifier in diagonal opposite way. This is a AC pin, AC, so I connect AC side and another AC pin to the other AC side. Keep in mind it's not in series. In any accident condition, if it is series condition, it is accident problem. It cannot though band just it's turn on and irritate me, and it is problem. What if series load is not turned on? If it's turned on, now I take these voltmeter, which I already connect the elevator clips. This time I will not connect a smoothing the capacitor right now. Remove old rectifier and carefully, so where's the positive and where's the negative, to connect them, and make sure there's no any short circuit in this. There's no any short circuit when I connect this, because this is a very high current. If anything is short, it can catch a fire. Carefully connect them like there. 6.7 volts, which is not enough. So what I tend to do now, it's time to measure that how much voltage this draws this bulb in series. So basically this bulb is acts like a resistor, so it is a limit or current flow into a transformer primary winding. Now I measure which amount of current is dropped off a bulb. So then this current is less than 50 volt is flow between this bulb, so I can direct it so that without bulb, if more than 50 volt is flowing to cross this bulb, then I not connect with parallel, because that's fire. So in order to do, we get maximum 250 volt range, because I don't think there's this voltage is 220 volt AC, so it is first I set the maximum range, so it cannot overshoot my multimeter. And this time we do very carefully, because this is high voltage outside. So it's showing somewhere less than, I cannot see too close. It sees 2, meaning it is a less than somewhere 20 volts. So I set in 50 volt range. Now it shows, keep in mind this is a HP voltage. Now it's showing, 6 volts. 6.5, meaning there are, we can also set 6 point, which means almost, right now it's set less than 50 volt range, and this time show 6. So meaning when it sees 40 volts somewhere, which is almost safe to direct it, but I not direct directly. We use a series with 1.5 amp fuse instead of this bulb, and then plug in and then check output. Now I connect a 1.5 ampere fuse in a very bad way, meaning I did not use any older, just I am use a demo. In your case you can use proper older, use older when you try this. And now we get similarly 7.1 volt, which is almost same. So what I tend to do next to increase the voltage. So in order to increase the voltage, so you may clearly see transformer some transformer is made of double wire. So secondary wire is made of two double wires in parallel. Increase the current. So what I then do, I connect these two parallel, remove the parallel wire binding and connect in series, which can increase the number of turns, which can increase voltage but decrease current. Now DC voltage is still 7.3. Now try with this capacitor with series. The capacitor is this side is negative and this side is positive. Always to that capacitor is the right orientation. If you have capacitor to the capacitor in wrong orientation, your capacitor door burst or in single just a 1 second. So always connect a capacitor in one proper orientation, red to red, and I know I use jumper wires, but I recommend you can use a proper safety wires, safety. I recommend you can turn off the power first. Well, do try something, because the capacitor is not a parallel with output of rectifier. If I later touch it properly, and needles will not short to each other. Voltmeters turn on. Yes, it's turned on. Now carefully hold this wire and touch a negative terminal of the capacitor. Once connect that capacitor is already charged, which may be little bit increase the voltage, but it's not a big deal, because capacitors, once the capacitor is little bit low, the capacitor will discharge and voltage will again drop. You can see in that ampere power supply. Right now you can see 11 volt, but it is unloaded voltage. When you overload this little bit load it by this lamp, you can see voltage is dropped. But not. It's still good enough. Just now we connect this wire over here and see how bright its lamp is turned on. It is a 12 volt 1 amp load, and it is not right too much current, so that's why voltage will not drop. Then overload, I'm a little bit apply more load, this capacitor discharge quickly and voltage still drop it, which is not routine. And now I made a setup completely. So what I tend to do, I not change much. So I take a heavy gauge wire and connect, instead of LED data clips, positive to positive and negative to negative, and I also connect the capacitor directly to 3300 microfarad by 35 volt capacitor directly to the DC terminals, negative to negative and positive to positive, that way. Now what I tend to do next, I take a power tool, which I connect a fuse holder, which I insert a 5 ampere ceramic fuse, 220 volt 5 ampere ceramic fuse. And right now what I can do, we can make a permanent setup. In order to make a permanent setup, we can need to touch this GST connector and somewhere over here. But before touching there, I am touching these zip ties in order to remove this ferrite. While length is little bit increasing, Now insert this scissor and cut this zip tie first, because there are this tool, fried tool, which can be normally used as a filtering the output, but right now filter the power. Right now I am used as a power supply. I cannot need this anymore, so I can cut this off, so it's takes there with a little bit length, while length is longer, which can right now blocked by these bit. So I can touch the zip tie. Zip tie is quite hard, and I hope I cannot touch the wire and damage the wire. It's a little bit extra force and it start out. These are zip ties. Tie is removed. Now this free. I cannot remove this one. I mean this tie. So if I remove this tie, it will make a problem. Now I cut a connector somewhere over here. So if future may I need to rejoin them, so I could rejoin it in the future. So there's a 4 wires. Like that. Now I touch the wires carefully. Touch this item. There's the item wires. It stays a little bit hard. Now remove this bead. Now I use white and black wire, because you may know I use white and black wires. White is common and black is third number wire. So we cannot use these 2 wires. So if you like, you can touch these wires over here, but I did not touch them. But this wire is still alive. Now touch it. And now what I tend to do, strip this wire out, just like that. And similarly other wire. Now I cut this wire because this is extra wire right there. Right now I use this type of plug because I don't have other types of wire right now, but you can use proper wire for use. Use kit wire computer power supply wire as possible, because it is carrying either wires. Now I carefully chop the wire. Now randomly I connect one of wire over there, because it is AC. AC is no priority. So one wire directly to there, another wire directly to the back of the fuse. And then I tape the one wire and then plug in and check it's do something wrong or it's what. Now I put the wires and hold it like that and tie the fuse. When tied, if you have like to soldering, you can do the soldering that, because there's it is the high voltage and inductive load. So if any joint is loose, it is produced sparking. So that's why I can tie it enough. Now we need a electrical tape. Electric tape. To cover all these wires. Once tape is completed, now this setup is ready, and I tell you I did not make a modification in here. Just video in start. So because I that after rectification and filtering proper 11 volts, it's almost close at 12 volts. So it did not need to any modified more. Now I also cover these wires, which is not used in air. Just it is not used, but still taping is required, because it will never short, because this wire is primary side wire. Now winding them.